Hi, everyone. We'll just wait for a couple of minutes so that we have everyone joining in live. Probably if someone could also start putting in some emojis in the chat, that would be super awesome. Great. Yeah. Awesome. Thank you so much, everyone, for joining in. Welcome to the last session of the day 2 of TestMu conference. I hope you're having a great time. I'm Kavya, and I'm thrilled to introduce this keynote session. Our keynote speaker, Anand, is co-founder and CEO of Patronus AI. Patronus AI is the industry-first automated AI evaluation and security platform that helps enterprises catch LLM mistakes at scale. Previously, Anand led ML explainability and advanced experimentation efforts at Meta Reality Labs and exited a quant hedge fund backed by Mark Cuban. In today's keynote, we are diving into the topic how to scalably test LLMs. Companies are excited by the prospect of generative AI, but they are equally concerned about the potential LLM failure models. So in this keynote, Anand will discuss the most reliably automated methods that you can use to test LLMs at scale. Let's get started. Please join me in welcoming Anand Kannappan. Anand, over to you.
Great. Thank you so much, Kavya, for the wonderful introduction. It's great to be here and very excited to be presenting at the keynote of the TestMu conference hosted by LambdaTest. So I'll go ahead and share my screen to kick things off. Awesome. Great. Well, thanks so much, everyone, for attending. Super excited to be talking about everything related to LLMs and generative AI, but especially how to scalably test LLMs. And so in terms of the agenda, what we'll go through is just a high-level overview of what the kinds of problems that we're seeing developers and QA testers around the world run into, especially when they are trying to understand how to test language models. We'll go into a little bit around what the basics of LM testing actually are, and then we'll do a couple of deep dives, especially as it relates to things like retrieval augmented generation and even more specifically AI security. And at the end, we'll have some time for questions as well. Great, super excited to jump into things. So for a quick introduction about what we're going to be talking about, like Kavya had mentioned, a lot of companies today are really excited about the prospect of generative AI, but also really equally concerned about a lot of different kinds of potential LLM failure modes. And of course, it's not just specific to LLMs, but it's about LLM systems and AI products and agents and everything that falls under the umbrella of generative AI. And some of these failures, of course, we've all heard about things like hallucinations, unexpected behavior, unsafe outputs, a broad range of different kinds of things. And I'd say what's unique about the world we live in, especially over the last couple of years, is that testing LLMs is very different from testing traditional software. And the key reason for that, of course, is there's just such a wide space of behavior, and there's this element of unpredictability, as we all know, given that we're working with models that are generative in nature. And so in this keynote, I'll focus on the most reliable automated methods, along with some unique trends and insights that we've seen, especially over the last couple of years. So for a quick background about myself and Patronus. So I'm co-founder and CEO of Patronus AI, and we help companies be able to do that exact thing, which is helping companies be able to scalably and reliably measure LLM and LM system performance in both online and offline settings. And what's unique about Patronus is that we have a strong AI research-first approach to how we solve that problem. And my background is primarily in ML interpretability and explainability. I led a lot of those early machine learning efforts at Meta, specifically the Meta Reality Labs org, which originally was just the Oculus team, but today it includes everything related to machine learning and AI research and everything else. And so many of the folks in our team have come from research backgrounds, including my co-founder here, who, for example, was also on the AI research team at Meta, helped scale Llama and Llama 2, and also led a lot of the responsible AI efforts across the organization. And so very excited to talk about some of those methods, both some of the things that we've seen in practice and also just starting with some of the research that we've seen as well. And of course, very excited to get into questions later on too. And so as we all know, LMs are today can be somewhat unreliable in production. And what's challenging is that there's really no easy way to test them at scale. And of course, we've all seen headlines like this, especially over the past year. And as we talk to developers and companies, we continue to hear about how people are concerned about seeing themselves in the headlines for the wrong reasons like these. And unfortunately, this is what happens when you don't have reliable AI evaluation. And so a question that I get often is, why is measuring LM performance so difficult? And what makes it different from traditional machine learning or predictive machine learning? And I'd say the big difference is that, especially when you're dealing with predictive models, you tend to have discrete outputs. But with generative models, by nature, they have a much wider space of behavior that makes it difficult to not just achieve testing coverage, but even just define what testing coverage even means. And so then what we've seen is that a lot of engineering teams are now spending a lot of effort on manually creating test cases and manually grading outputs in spreadsheets. And some of the largest companies now have large internal QA teams and external consultants that are focused on this exact problem. And of course, as we all know, there aren't really any established frameworks around unit or integration testing for language models. And as a part of all this, there are a lot of things, of course, that you want to make sure you understand when you test language models. And so that might be understanding whether a new model version is better or worse than a model version. So, for example, is GPT-4o better or worse than GPT-4? It might also involve comparing one commercial foundation model versus another one. It might be the difference between GPT-4 and Cloud 3.5, for example. Of course, we also, many of us might know about fine-tuning language models. And the most challenging thing about fine-tuning is actually quantifying the ROI of fine-tuning. And so being able to understand whether a model has gotten better after fine-tuning versus worse is also a really challenging problem for that exact reason. And apart from all of this, of course, we've seen a lot of different kinds of benchmarks that are developed over time. But unfortunately, many of these benchmarks don't actually focus on practical scenarios. They tend to focus on academic types of questions like 11th standard history questions or medical entrance exam questions, and not as much about scenarios related to things like financial services or customer service, for example. And so we're seeing that the problem space has become really, really challenging and complex to figure out. And of course, the entire world of AI is moving extremely quickly, which has just exacerbated the problem. And so I'm now going to focus a little bit on what some of these actual basics are when it comes to what LM testing actually means and how to start thinking about it from a high level. And so the first thing that's important to know is the difference between intrinsic evaluation and extrinsic evaluation. And so how to think about intrinsic evaluation is it just tells you and helps you measure whether or not the model actually captures what it's supposed to. And so that might be things like log probabilities, for example. And so the way that you would measure something like that would be with traditional NLP metrics like perplexity or blue score or things along those lines. And ultimately, these are important metrics because you want to make sure that if you are training a language model or if you're fine tuning, you want to make sure that you're evaluating and measuring improvements along the way, especially as you go through that process. And so that's where intrinsic evaluation is important. The focus of this presentation and the focus that most people have today is not as much about the intrinsic evaluation, but it's actually about the extrinsic evaluation. So extrinsic evaluation actually tells you about how well the model actually does against a particular task. And so this might be a task that I mentioned earlier, like answering questions around finance or serving as a customer service chatbot, for example. And so that's where the ways that you measure performance become more important, especially for end user applications. And that's exactly where you would think about how to scalably test language models, especially before you put them into production, and especially before you roll them out to your own end users, for example. And so this might be an example around a transcription task where you want to be able to understand two different language models and understand how well they perform against that particular task and determine which one does better. And so let's focus on extrinsic evaluation in particular here. So an example of how to do extrinsic evaluation is to use a benchmark and understand if the language model system that you're developing actually does well against a benchmark. And after you test the model against every single example in a benchmark, you'll then see what the score you actually get will be. And a couple of the early popular benchmarks included the glue benchmark, as well as the next version of that, which was the super glue benchmark. So glue was actually one of the first popular benchmarks for BERT and GPT-like models, and it became really popular in 2018. And you can see some examples here around what that looks like. And as you can see, glue included a number of different kinds of evaluation data sets that were bundled together to produce the whole benchmark. And so what was interesting about glue was that it ended up becoming saturated fairly quickly, especially as we saw language models improve really significantly. And so after that came superglue. And so superglue was a better and improved benchmark that had a lot more challenging tasks, more diverse formats. It even had human baselines, so understanding how humans might score on them, for example, along with even a public leaderboard. And so these were some of the earlier benchmarks that became really relevant and popular, especially for measuring LLM system performance. And so, kind of like I just alluded to a few seconds ago, what's become challenging is that measuring progress in AI has become very confusing, mainly because a lot of the benchmarks have become saturated over time. And I actually say that there's two reasons for that. One reason is LLMs have, of course, become much, much, much better than they even were a couple of years ago. Along with that, of course, many of these benchmarks were actually open sourced, just to make sure that folks ultimately understood what was in the benchmark, what the results look like, and of course, making sure that everything was incredibly transparent and accessible. But the problem with open sourcing benchmarks is that there are developers, LLM developers out there that actually go ahead and train on those high quality benchmarks and data sets. And of course, I would say that training on an evaluation test set is exactly the thing you shouldn't do when we talk about ethics in machine learning. But unfortunately, that's what a lot of people have done in the last few years. And folks are doing that in order to say that they have the best model and that they're the state of the art and that they have the best one. And that, of course, has then made it very difficult to actually understand how good is AI today, and how can we actually measure whether we're getting to AGI in the right way in the long term. And so some of the things that we have developed at Patronus AI has been focused on being able to solve those kinds of problems, especially from a benchmarking perspective. And so one of those things is to focus on practical use cases like financial services, as well as things that involve more enterprise types of capabilities, like being able to detect business sensitive information, for example. But along with that is making sure that the benchmarks that are released are not fully open sourced. And so this was something that we actually did with Finance Bench. So with Finance Bench, we open sourced a sample from the full benchmark that we created. And that sample is on Hugging Face. And today it's been used by a variety of different kinds of organizations like Stanford University, University of Waterloo, regulatory groups around the world, along with lots of large financial services companies as well. And a lot of them will start with the open source sample from the benchmark, but the rest of the benchmark is actually closed. And that's a something that we actually offer through Patronus, so that companies really are able to understand and actually trust the evaluation results that they're seeing. And so these are some of the examples of things that we've done to combat some of the problems that we're seeing, especially as it relates to quantifying performance. And so a common question that comes up is, okay, I'm a developer, I've developed an AI product, and I want to understand how can I actually guide my language model system in the right way? How do I make sure that I can make the right kinds of improvements as a developer so that it ends up becoming more aligned to what the actual use case is and what my user actually needs and what they should ultimately expect. And so there's a few ways to actually do this. One is to actually uh, uh, figure out the right way to make adjustments to the original prompt. Of course, this is the fastest and perhaps even the simplest way to do this. And this might be where you include a lot more context about the domain itself. And so with prompting, there's a few different variations on how you can get it to give you better performance. So there's things like zero-shot learning and few-shot learning. Few-shot just means that you're adding more examples to the prompt that is specific to the domain that you care about to make sure that the results that you're seeing from the LLM are in line with that particular domain. And so that's what number one is here. Number two here is actually probably one of the harder ones, which is where you can actually pre-train a language model completely on the domain data itself. And so this is something I would not necessarily recommend a developer to do because, of course, it's extremely expensive to do that. It will require lots of money for compute and, of course, lots of perhaps even lots of GPUs. But this is something that that will help you make sure that the language model that you ultimately use in a system is more specific to that particular domain. The third one is easier than number two, but harder than number one. And this is where you can fine tune an existing base model on that particular task itself. And so this is where you don't necessarily need lots and lots of data. You don't need lots of computer infrastructure, but you can use a fine tuning platform that's out there to help you guide the model in the right direction on a much smaller data set that you've curated yourself. And so this has become a popular approach for developers, especially machine learning practitioners, to be able to make sure that you can constrain the outputs in that particular domain. The third way is to, the fourth way is to do this with reinforcement learning. And so this is also a more complex approach, but this is where you can have approaches that involve human feedback or AI feedback. RLHF stands for reinforcement learning with human feedback. RLAIF stands for reinforcement learning with AI feedback. They're just two approaches to ultimately help you develop a reward model that also ultimately guides the language models in the right direction. And so when we talk about ways to actually measure performance after you've done something, that's where it starts to get a bit challenging as well. And so today, there's a lot of different kinds of ways to evaluate language models themselves. And like I mentioned before, the focus is really around extrinsic evaluation here. And this is where you care about being able to measure on specific types of domains and applications. And so this might involve general dimensions across safety and security categories. It might involve specific types of evaluators for things related to the brand or the tone of voice or the style of the chatbot that you're developing. Or it might involve something that brings in your own internal knowledge base or your internal data sets. It might involve PDFs that you have or JSON files. And that's where the retrieval and the RAG system piece of it comes in. And that's where you want to make sure that the RAG-based product does ultimately produce results that are as correct and factual as it can be according to the data sets that you've plugged in, along with some other measures around quality of that data and other things to make sure that you're going in the right direction. And so when you use an evaluator, the goal is to ultimately get a score, and that score will give you a sense of what that system looks like today. It'll give you hopefully a ballpark in terms of what that looks like as a baseline in terms of what you've done today, maybe perhaps compared to what you did yesterday. And this is something that you can ultimately use to iterate on over time, so that you ultimately have a much higher performing system that works really well in both offline and online applications. So one thing that I thought I would mention in terms of a unique trend, this is actually from a research paper from a couple years ago, is that we're starting to see some carrying capacity around how much better language models can actually get. And so there's some estimates that show that high quality LM training data might actually run out by 2026. And so this is from a couple years ago, so perhaps some of these numbers might be different now. But what's interesting is that at some point we will get to a phase where we've actually run out of really high quality data. And as we all know, language models have been trained on large amounts of high quality data today, including, for example, Wikipedia, which tends to have generally tends to have really high quality information. And so what's remaining now is two things. One is low quality data, which might be, for example, perhaps comments on social media like Reddit or Instagram, for example. But two is actually the ability for companies and developers to actually create high quality synthetic data sets. So synthetic data sets can help us continue to push the envelope in terms of how much better language models can get over time. And so some of the things that I'm excited about personally, and especially all of us at Patronus, is the long-term vision around scalable oversight. And so this concept of scalable oversight really came out around the end of 2022 in a research paper from Professor Sam Bowman at NYU at the time. And it was this idea around how will humans actually supervise systems that far outperform them. And at some point, maybe it's already there, but at some point, that'll become really challenging to do, especially in more scalable ways. And so this is where we see a long-term vision around how AI will evaluate AI, and along with domain experts, be able to make sure that we can scalably supervise really powerful systems that will continue to be in use and continue to be things that we perhaps not only develop but even coexist with over time. And so really excited about the pathways towards scalable oversight. And we think about it almost like a player coach model or a student teacher model, where you have AI and domain experts together that are able to train, evaluate, test, measure, and ultimately make sure that other powerful AI are trending in the right direction ultimately, and are ultimately aligned with what humans really want and prefer at the end of the day. And so one of the next things that I'll focus on here is to do a deep dive on RAG evaluation. We just talked a little bit about it, but wanted to double click on this just because it is something that has become a really important question for a lot of developers around the world, especially over the past year, where RAG applications have become one of the primary ways in which developers are creating new AI products. And so this is where you have an internal knowledge base or set of data, like I mentioned, that ultimately is informing how the AI product will answer user queries at the end of the day. And so the way to think about this diagram is the retrieved context here at the bottom is that underlying data set, and it's actually a snapshot, or you can think of it as a chunk that's being pulled from the data store itself. And so in this example, what you can see is, let's say that you have built a product that is helping your user be able to ask questions about a lot of things related to soccer players, and so, or let's say football players. And so with something like this, maybe a user asks the question, who is David Beckham? And so what then might happen is the language model will pull in the right kind of relevant, ideally relevant context and information to be able to really support and answer that question. And what you can see here was that it identified, based on the parameters that were set up by the developer in the RAG system, it identified three high-level bullet points on how to answer that question. One is David Beckham is a former player who played for Manchester United and Real Madrid. Another is David Beckham is the president and owner of Inter Miami. And then the third is David Beckham is married to Victoria Beckham. And so, as you can kind of see here, there are actually three plausible answers on how you would answer that question. And so this is, of course, a potentially ambiguous scenario. And this is exactly where you would want to make sure that the context that's being pulled in is as relevant as it can be. And at the end of the day, that is what is informing what the model output is. And so here, based on the, let's say the context that came in, the output that ended up being decided to be displayed to the user was David Beckham is a soccer player of Manchester United. And so in this case, if, for example, it said something about how David Beckham is a tennis player, or it said David Beckham is someone who grew up in Australia, for example, that would be something that should be captured as a hallucination. And so when you think about test data sets, sometimes you'll also have gold answers, which is also what all benchmarks have. And gold answers are just ways for you to verify whether or not the model output was correct or not. And so as you can kind of see here, if we extend the example with the gold answer, what it should have been is David Beckham is the president and owner of Inter Miami. And so in this kind of case, if you are using an evaluator for correctness, you should of course get a score that tells you that the model output was incorrect compared to the gold answer. And of course, as you can see here, these are both sentences and they ultimately depend on semantic meaning at the end of the day. So there isn't it isn't a discrete output that you can just compare side by side and make sure that you can check to see if it's equal or not. But you do have to understand whether or not the answer itself is similar in semantic meaning to the gold label. And so each of the purple boxes in this diagram is the exact are the exact sets of things that you'd want to make sure you have really powerful evaluators for, especially while you are testing a very complex system like a RAG system. And so those are the five purple boxes you saw here is exactly what these metrics actually are. And so that includes things like measuring for answer hallucinations, answer relevance, context relevance, answer correctness, context efficiency. And each of these things are all very, very important to making sure that you get a very high performing system at the end of the day. So when we think about ways to improve RAG systems, if you're a developer, I would think about a lot of different kinds of ways to iterate on the performance. So the ideal workflow is you might, for example, start with a really high quality evaluation test data set, and then you get a set of scores across all the values I just mentioned. And then from there, you're thinking, okay, maybe some of these scores aren't good. Let's say that maybe it might be specifically the hallucination one, or maybe specifically the context relevance one. And so depending on the scores, and specifically the ones that had lower scores, there are a number of different strategies that you can take to be able to improve the system so that the next time you actually run the system against the data set, you ideally will get better scores. And so that might involve exploring different indexer types. Or, for example, thinking through your chunking strategy, whether it's a small chunking strategy or a large chunking strategy. It might also be something where you should experiment with the base prompt that you're using for the language model itself. There are also other things like modifying your retrieval algorithm, or even modifying the specific embedding model that you've chosen, or even whether or not you should be fine-tuning your embedding model. And so as you can see, there's a lot of different potential pathways to actually improve your RAG system. And ultimately, it really depends on the specific domain you're working on, and of course, the specific underlying type of data that you're dealing with at the end of the day. And so because it becomes a very iterative workflow, there are these are the kinds of strategies that you should, of course, take very seriously as you are iterating on the performance of the system over time. And so I would think about the key takeaways of what we just talked about is the fact that we talked a little bit about intrinsic and extrinsic evaluation metrics. And as we know, extrinsic evaluation is what many folks today are focused on, especially because intrinsic evaluation metrics tend to be better for understanding the performance of a model, especially as you're going through the training iterations. And so using an intrinsic evaluation metric like perplexity would not be something that would be good for task-specific scenarios. And because of things like perplexity that tend to be weakly correlated with human judgments. Along with that, as you can kind of see here, it's definitely as much of an art as it is a science in terms of how you can actually scalably and reliably test these kinds of systems. And so it's always really important to make sure that the test data sets that you've put together are very diverse in distribution and that they are covering as much of the entire use case scope as possible. And the third thing we talked about was benchmarks today and what are some of the challenges with them and why today a lot of developers are figuring out ways to not only construct their own evaluation test data sets, but also even work with partners or companies that can help them do that. And that's because open source benchmarks have tended to be focused on academic questions in the past, but also many developers have already trained on them. And so because of that, you can no longer trust that that models that perform well on them are actually really good at things that go beyond those benchmarks. So that concludes the presentation that I have, and happy to answer any questions anyone might have.
Great, Anand. So thank you so much for that, very interesting session. We have a couple of questions. Let me just pull that up onto the screen. So this question is from Pratul. He wants to know, will an agentic RAG system produce a better result than a modular one?
Yeah, definitely. That's a good question. So ultimately, it really does depend on the specific things that you have defined in terms of the parameters that you've set up for the RAG system itself. And I'd say that there are a variety of different kinds of challenges, especially when you are working with agents as opposed to working in more modular formats. And so the challenge with agents is, of course, there are multiple steps in a workflow, and there are a lot of consecutive actions that have to work for that to make sense. And so that means that you actually have to be able to evaluate every step of the workflow at the end of the day to make sure that the agentic RAG system performs really well. And so agentic RAG systems tend to be more complex for that exact reason. So you can imagine, for example, let's say you have an agent that you're using to perhaps pull together some data, maybe scrape from a website. Maybe the next step is to put that into a CSV. Maybe the third step is to write an Excel formula that produces some calculations. Maybe the fourth step is to create a chart in Excel as well, or maybe a different tool of that kind. And as you can see, if even step number 1 fails, then of course step number 4 will certainly be a failure. And so what we're seeing with agents and agentic RAG systems more specifically is you certainly want to make sure that you prevent those kinds of cascading failures from happening. And the best way to do that is to make sure that you plug in the right kinds of evaluation and tracing and observability tools to make sure that the performance of all of that goes incredibly smoothly so that you don't end up with cascading failures.
Thanks so much. So bringing up the next question onto the screen. So this is from Viju, who wants to know what metrics can be used to reliably assess the performance of LLMs, given the limitations of traditional metrics like perplexity and the diminishing trust in open source benchmarks.
Definitely. So this was some of the focus of some of the earlier slides in the presentation as well. And it's a great point that, of course, traditional metrics like perplexity are better for intrinsic evaluation, but not extrinsic, which is primarily what everyone cares about today, especially when using language models. And so some of the metrics I showed earlier, especially in the context of RAG systems, are the ones that I would recommend to better reliably assess performance. Things like measuring for context relevance or context efficiency or output hallucinations are really important. There are also other kinds of metrics that we didn't get into in this presentation, like LLM as a judge approaches that companies have also used. So, for example, using GPT-4 to evaluate GPT-4, for example, that's become a more popular method that we've seen developers take, especially over the past year. And there are limitations to those kinds of approaches as well, because ultimately a model like GPT-4 was not designed by nature to actually be a really good judge model. And so when you're repurposing it to do something very specific in that setting, those become perhaps unreliable metrics as well. So in those kinds of cases, I actually recommend if you were to use an LM as a judge approach, I recommend using a model that was trained to be a really powerful LM as a judge, as opposed to using GPT-4. An example of that is actually a model called LYNX, LYNX. It's actually an open source model. It was actually trained and open sourced by us at Patronus just a month ago. And that's something that now developers today are using to test for hallucinations in RAG systems more reliably. And the approaches there have shown to outperform other LM as a judge approaches, including GPT-4 and Cloud and others. So recommend checking out links on Hugging Face if you're interested in learning more.
Awesome, thank you. Bringing up the next question onto the screen, which is on the ethical standards. So Mahesh wants to know, how do you ensure that LLMs maintain ethical standards and avoid biases when tested across large data sets and varied user inputs?
Absolutely. Yeah, I would say that this is, of course, a really important question because evaluation is not necessarily just about testing and quality, but it's also about understanding whether or not you can adhere to ethical standards and regulatory standards that are now increasingly becoming more common, especially today and also in the next few years. And I would say that it's really important to make sure that you work with the right platform, with the right evaluation framework that can help you with that. And today there are already responsible AI frameworks out there like MNIST and MNIST that help set those kinds of standards. And there are evaluators actually that are even supported by Patronus that support those kinds of use cases. And those generally fall across areas like safety and security. So in the context of safety, that includes things like detecting for toxic content or unsafe outputs in a variety of different both marginal but also more generic categories around AI safety. Then there's also the security side of things when it comes to standards, which might involve things like prompt injections or insecure output handling or excessive agency and things like that. And so all of those different kinds of evaluators are supported on Patronus. I thought I'd mention as well that, of course, you can make an account on Patronus today and try it out for yourself. And it's a product that's available to everyone around the world. And these are all the kinds of things that we're hearing developers care a lot about, especially as they're developing their LM systems.
Absolutely, I can see a lot of thumbs ups and emojis coming in. Coming up is the next question from Abel, who wants to know what would be the challenging issues with cost facing the scalability of LLM due to the nature of them needing a lot of space server and heavy use of graphics. That is when it comes to training, retraining, and subsequent role as a QA to play.
Yeah, definitely. That's a great question, especially on the focus around the necessity to potentially retrain or continue to rerun things. I would actually say that the costs of not just training LLMs, but even using LLMs in terms of inference has actually been going down significantly over the last couple of years. And perhaps some people call it today's version of the Moore's Law to some level, just given generally how that has been for folks that are getting into generative AI more broadly today. And so I would actually, my opinion is that over time, the costs will continue to decline. And it'll be much, much more accessible for folks to be able to do this with as little cost as possible. This is also an area where I also recommend, if cost is a concern, to actually use smaller models, which tend to, of course, not only require less compute, but also might even be things that you could use locally. And so small models today have already improved dramatically, even from a couple of years ago. And so to do this, even from a QA setting with models like LYNX, is exactly what I recommend, where today you can use LYNX locally if you use the Ollama package, and you'd be able to do the exact same kind of thing that someone else might do with GPT-4 or with a very large model that they've hosted, but to do that completely without any kind of infrastructure needed at all. And so the 8 billion parameter model for LYNX is something that you can use completely for free and completely locally because it's open source.
Thanks, Anand. Picking up one more question, this is again from Pratul, who wants to know if there is any specific model that goes well with RAG or any particular frameworks like LangChain or LambdaTest that suits a RAG system.
Yeah, absolutely. I'd say that there are a number of companies that are working on new retrieval augmented generation models today that tend to be really good at RAG specific types of applications. One company that's doing a really great job at that is Contextual AI, and they have developed a number of approaches and have published a lot of research in the space as well. And they are at the forefront of developing new and very powerful models that are specifically great at these kinds of applications. But I'd broadly say that, of course, all of the state-of-the-art models that we're all familiar with are all the kinds of models that today developers are using with RAG systems. Because ultimately, in a RAG system, the language model itself is just one piece of it, but there are other things like the embedding model, as well as, for example, the vector database or the vector store that you might be using. And so if we're talking about embedding models in particular, there are some really great ones out there. One that I might recommend is the Nomic embed model. So Nomic embedded model is also a really small model that is really powerful. It's also on Hugging Face. It's available on open source for free. So if you are trying to understand whether to use an embedding model like that, I would definitely recommend the Nomic embed model.
Thank you. Now we have a question from Ozzy who wants to know what are some of the measures used for improving the accuracy of the LLMs?
Yeah, definitely. So this goes back to the slide that I had around Patronus evaluators along with the evaluation framework. And so there's a variety of different ways to test LLMs. And because it's focused on individual domains and tasks, it's important to make sure that you are not only choosing the right evaluator, but in some cases even creating the right evaluator to do that in the most powerful way. And so depending on what specifically you're working on from an application standpoint, it's important to be able to set that up well and correctly and make sure that that you have a systematic but scalable way to do that with the right kind of tools and the right kinds of capabilities.
Thank you. And we have a question from Dina, which is on what kind of learning models would you recommend leveraging for? I think we sort of covered it. Great. Let me just quickly take a look and see if there are any other questions that are coming up. I think we have mostly covered everything. Thank you so much, Anand. Really appreciate this. I can see in the chat that there has been some great feedback from the attendees. Amazing presentation, Anand really, helped us get a lot of insights. To the attendees, please connect with Anand on LinkedIn, as well as you can follow Patronus AI's work very closely through their channels. I also want to remind all the attendees that all these sessions are recorded. So in case you have missed Anand's beginning session, for instance, starting of the session, you could go back and see it in a bit, or you could watch it on YouTube channel. Anand, really appreciate you for joining the keynote session. It was a pleasure hosting you. Thank you so much.
Definitely. Thank you so much, Kavya, for having me. And I want to say a big thank you to all the organizers of the TestMu conference and everyone at LambdaTest that has made all this possible. And the best is yet to come.
Awesome. Thank you so much, everyone. Have a great day.